Which leads me to number 5, which is the source of the most confusion. Radiant intensity. I will never do that to you. I will never call irradiance as intensity, but some textbooks do. The symbol for radiant intensity is IE, and the formula for this is d phi E over d omega, where omega is the solid angle. So this is defined as power per unit solid angle. So do we all know what this is? What do we call this side? R. What do we call this side? Arc length. And what was the symbol of arc length? S. This is a one-dimensional circle where R is the radius, theta is the angle, and S is the arc length. Now, what about if you have a sphere? So in a spherical case, if I have the same problem, instead of having the arc length S, you will have an area. Solid angle was equal to sine theta d phi. So what is a solid angle? A solid angle, its unit is called steradians, S-T-E-R-A-D-I-A-N, and it is used to describe 2D angular spans in 3D space we live in. So if you have a sphere and you wanted to define what this tiny part of that sphere is, you would take the center and figure out what the angle is to that edge. And that is called a solid angle. Good? So that is called the radiant intensity. It is, oh, I never gave you a unit for this. So the unit for this is watts per SR, steradians. So radiant intensity is if this is a source and this is your area and this is the radius R. Think of this central ray going forward. This is your dA, and that defines what your d omega is. So radiant intensity is the radiant flux phi E emitted per unit solid angle by a point source in a particular direction. Good? Okay, number 6. Radians. The symbol for radians is LE. It describes the radiant intensity per unit of projected area perpendicular to the specified direction. It is defined as DIE over cosine of theta dA, or simply d squared phi e over d omega cosine theta dA. Its units are watts per meter squared radians for a solid angle. Where this, remember, is the solid angle, this angle, theta, is the angle between the surface, normal, and the direction. dA is the area of the surface. That things are being irradiated on. So if I look at this, what does that look like? So imagine that this is my source, okay? And this is my observation point. This is my area of observation. Then that will be my theta. This will be my R. That will be my area, what I'm talking about. And this is my d omega angle. That. And that's my theta.